Hi, students. How are you today? Welcome to Top Tutors, Toppers e-learning classes. Understand every single concept and be a top. Today, we are discussing 10th grade Cbse mathematics, chapter number 1, exercise 1.4, second question and third question. In second question, there are 10 sub-questions are there. Similarly, in third question, there are 3 sub-questions. All these questions we can do today. This exercise is based on decimal expansion of rational number. We have already learned in the previous session the decimal expansion of rational number. Let us recap. Decimal expansion, two type. One is terminating, other one is non-terminating. Terminating again, there are two type. One is recurring. Recurring means repeating. Then non-recurring, non-repeating. So there are 3 types of decimal expansion. One is terminating, second one is non-terminating recurring, non-terminating, non-recurring. If the decimal expansion is terminating, that number will be a rational number. We have learned that. And if the decimal expansion is non-terminating and recurring, non-ending and repeating, then it is also a rational number. If the decimal expansion is non-terminating and non-recurring, non-ending and non-repeating, it is coming under irrational number. Irrational number. In the previous session, we have learned a rational number. Its general form is P by Q form, where P and Q are integers and Q not equal to 0. Without doing our actual division, just by checking the nature of the denominator, we were expressing whether it is terminating decimal expansion or non-terminating recurring decimal expansion. Okay. In this session, what we have done in the previous session, we are just cross-checking using our normal division method, traditional division method. So this is a good practice for division also. Most of the students, they don't want to do the decimal, the division part. Okay, from my teaching experience, most of the students, they will try to use calculator when they are doing homework, all this. But you have to practice it, because we cannot use the calculator for the examination. So compulsory, we have to practice. So it's a good chance to practice that. So let us start. Now, in the decimal expansion of a rational number is terminating. Without doing division method, how we can check the whether it is terminating? We can say that prime factors of denominator is of the form 2 raised to m into 5 raised to n. So it contains only 2 or only 5 or both 2 and m in the prime factorization of denominator. Then it's coming under terminating decimal expansion. And if prime factors of denominator is not of the form 2 raised to m into 5 raised to n, other than 2 and m, even 2 and 5, some other numbers are also there, like 3, 7, 11, etc. are there in the prime factorization. Then it is a rational number with non-terminating and recurring. It will come in this series. Okay. Now, let us start the exercise. 1.4, second question, first sub-question. Write down the decimal expansion of the following rational number, 13 by 3125. We already found that prime factorization of the denominator, that is 3125, It is in the form of 5 raised to 5. So it contains only 5. So it is in the form of 2 raised to m into 5 raised to n form. So the decimal expansion is terminating. Decimal expansion is terminating. This fact we are just cross checking by doing our traditional division method. How we can do the division? So let us do the division. 13 divided by 3125. We are using our traditional method of division. Here we have 13, dividing it by 3125. So as a traditional method, take one digit. How many times? 0 times. 0 multiplied by 3125 will get 0. Then subtract 1 and 0. So we'll get 1. The next digit we have to bring down. So we get 13. 13 also small, right? So how many times? 0 times. 0 multiplied by 3125. We will get 0. Subtract. So you get 13. Nothing to bring down. Nothing to bring down. So what you have to do? You have to give a decimal here in the dividend and also in the quotient. And we can put zeros, as many zeros as you need. Fine. So we put some zeros there. I am bringing this 0 down. So the number become 130. 130 also small, smaller than 3125. So it's 0 time. 0 multiplied by 3125. I got 0. Subtract. So you've got 130. Bring this 0 down. So it become 1300. Again, it's small. Then the dividend. How many times 3125 goes in 1300? 0 time. 0 multiplied by 3125. You got 0. Subtract. So 1300. Bring this 0 down. So we got 13,000. In 13,000, how many times 3125 goes? 4 times. So 4 multiplied by 3125, you will get 12,500. On subtraction, you will get 500. So bring this 0 down. So it is 5,000. 5,000 bigger. How many times? 1 time. 1 multiplied by 3125, you will get 3125. On subtraction, you will get 1875. 1875. Bring this 0 down. So we got 18750. 18,750. How many times 3125 goes? 6 times. 6 multiplied by 3125, we are getting exactly 18750. On subtraction, we will get 0. So it is finished. It's a terminating decimal expansion. 0.00416. Okay, as a normal convention, we will not write 2 zeros before the decimal, only we'll take 1 0. Correct? So we'll get 13 divided by 3125 equal to 0.00416, terminating decimal expansion. Understood? Clear? Next question is 17 by 8. By checking the decimal prime factorization of the denominator, we found that it is terminating, because prime factorization of denominator 8 is in the it is equal to 2 to the power 3, 2 raised to 3. So it is in the form of 2 raised to m into 5 raised to n form. So its decimal expansion is terminating. That fact we are just cross checking using our normal division. So we have to divide 17 by 8. Let us see. So 17 by 17, we are dividing it by 8. 17. How many times? How many times 8 in 17? 17 we are dividing by 0, by 8, right? So 2 times. 2 8s are 16, right? 2 8s are 16. Now subtract 17 minus 16, we'll get 1. So bring this. Okay. So after that, we have to put a decimal here and put a decimal here also. We can add zeros, as many zeros what we need. Bring this 0 down. So we got 10. In 10, how many times? 1 time. 1 into 8 is 8. Subtract 10 minus 8, we got 2. So we have to bring the next 0 down. 20. How many times? 2 times. 2 into 8 is 16. Subtract 20 minus 16, we got 4. Bring one more 0, next 0 down. We got 40. How many times 8 goes in 40? 5 times. 5 into 8 is 40. 40 minus 40. So it is finished. It is terminating. Terminating. So we got the answer 17 by 8 equal 2.125. So it is a terminating decimal expansion. Fine. Okay, let us go for the next one. 64 by 455. On the prime factorization of 455, in the previous session, we found that 455 its prime factorization is 5 into 7 into 13. So other than 2 and 5, there's no 2 but 5 is there. It contains 7 and 13. 64 divided by 455. Let us divide 64 by 455 by our long division method. Now, take first digit 6. How many times 455? 0. 0 multiplied by 455, 0. Subtract 6 minus 0 is 6. Bring this 4 down, so it is 64. 64 is small. How many times 455 and 64? 0 times. 0 multiplied by 455 is 0. Subtract, so we'll get 64. So nothing to bring down, so we have to put a decimal here. We can put as many zeros what we need. You have to put a decimal in the quotient also. Correct? Now, bring this 0 down. So we got 640. How many times 455? 1 time. 1 multiplied by 455, we are getting 455. Subtract, we will get 185. Bring this 0 down. So 1850. In 1850, how many times 455 goes? 4 times. 4 multiplied by 455 is 1820. 1820. On subtraction, we will get 30. Bring next 0 down. So we have 300. In 300, how many times? 300 is small, so it is 0 times. 0 multiplied by 455 is 0. On subtraction, we are getting 300. Bring next 0 down, so it is 3000. In 3000, how many times 455 goes? 6 times. 6 multiplied by 455 is 2730. On subtraction, we will get 270. Bring next 0 down, so it is 2700. 2700 divided by 455, you will get 5 times. 5 multiplied by 455 is 2275. Subtraction, we will get 425. Bring this 0 down, so we have 4250 divided by 455, we will get 9 times. 9 multiply by 455 is 4095. On subtraction, we will get 155. Bring this 0 down. So it is 1550. How many times 455 goes? 3 times. 3 multiplied by 455, we are getting 1365. On subtraction, it is 185. 185. Okay. So just see here, now we got 185. Before also we got 185. What is it? Here. So now from this onwards, it is going to repeat again. Okay. So bring this 0 down. So we got 1850. How many times? 4 times. 4 multiplied by 455 will be 1820. So we'll get 30, right? 30. Now again, if you want, you can bring 0, but it will happen like this. You'll get 300, right? Again, 0 times, so it will repeat. So what is the repetition block? After 1, 406593. That is the repetition block, correct? So it is non-terminating repeating. So 64 divided by 455, we will get 0.14065934065993, 406593. That part will repeat again and again. So this is a non-terminating repeating decimal number. Okay, fine. Next, 15 divided by 1600. On prime factorization of 1600, we found that it is equal to 2 raised to 6 times 5 raised to 2. So it contains only 2 and 5. So it is in the form of 2 raised to m into 5 raised to n form. So its decimal expansion is terminating. So let us see by our normal division method. Okay, let us start division. Okay. We will take 1 digit. How many times in 1? 0 time. 0 into 1600. 0. On subtracting 1 minus 0, we'll get 1. Bring this 5 down, so we'll get 15. In 15, how many times? 0 times. 0 times 1600, we got 0. 15 minus 0, we'll got 15. Bring, so 15, nothing to bring down. So we are putting the decimal in quotient and also in the dividend. Then we can put as many 0 what we need. So this 0 now we can bring it down. So we'll got 150. In 150, how many times? 0. 0 times 1600 is 0. Subtract, we will get 150. Bring next 0 down. So we got 1500. How many times? Still 1500 is small, 1600 is big, so 0 times. 0 times 1600, we get 0. Subtract, so 1500. Bring next 0 down. 15,000. In 15,000, it will go 9 times. 9 times 1600, we will get 14,400. On subtracting, we will get 600. Bring next 0 down. So we have 6,000. In 6,000, how many times 1600 goes? 3 times. 3 times 1600 is 4,800. On subtracting, we will get 120. Right? No, 0 and 0, 0, 0 and 0, 2. So it is, we are getting 1,200. 1,200. Bring next 0 down. So we have 12,000. In 12,000, how many times? 7 times. 7 times 1600 is 11,200. On subtracting, we will get 800. Bring next 0 down. So we have 8,000. In 8,000, how many times? 1,600 goes 5 times. 5 times 1,600, exactly we are getting 8,000. So we end up with the remainder 0. So the division process completed. It is terminating. Terminating. Okay. So 15 by 1,600 decimal expansion is terminating. That is equal to 0.009375. Fine. So let us go for the next question. Fifth one. Fifth sub question. 29 divided by 343. Prime factorization of 343, we got 7 raised to 3. So there is no 2, there is no 5. Other than 2, 5, we have 7. So what is the meaning? It is non-terminating, non-terminating, repeating, non-terminating, repeating. Let us do the division. See here, we have 29 divided by 341. In 2, how many times? 0. 0 times 341, 0. 2 minus 0 is 2. We are bringing 9 down. In 29, how many times? 0 times. 0 times 341, again 0. Subtract, we have 29, right? After that, nothing to bring. So we can put a decimal both in the quotient and the dividend, and we can add zeros. So we can bring now next 0 down. So we got 290. How many times? Still 290 is smaller than the divisor, so it is 0. 0 times 341 is 0. Subtract, we will get 290. Bring next 0 down, so we got 2900. Now is bigger number. How many times? 8 times. 8 times 341, we will get 2728. On subtraction, we will get 172. Bring next 0 down, so we got 1720, bigger number. How many times? 5 times. 5 times 341, we will get 1705. On subtracting, we will get 15. Bring the next 0 down, so 150. 150 smaller number. So how many times? 0 times. 0 times 341 is 0. So on subtraction, we will get 150. Bring next 0 down, so it is 1500. How many times? 4 times. 4 times. 4 times 341, we will get 1364. On subtraction, we will get 136. Bring next 0 down, so 1360. How many times? 3 times. 3 times 341 will get 1023. On subtraction, we will get 337. Bring next 0 down, so we'll get 3370. How many times? 9 times. 9 times 341 is 3069. On subtraction, we will get 3010. 301. Bring next 0 down. So 3010, how many times? 8 times. 8 times. 8 times 341 is 272. So here again, 8 is repeating. 8 is repeating. Correct? So we got the repetition block. 85043 is the repetition block, right? So we get 29 divided by 343 is 0. One more 0 is there, right? Typing mistake, so correct it. We have a 0 here. Then 850,439, 850,439, 850,439. It will repeat. So non-terminating, repeating number it is. Next, sixth one. 23 divided by 2 raised to 3 into 5 raised to 2. So on decimal, the remainder is, I mean, the denominator is already given in the form of prime factorized method. So it contains only 2 and 5. So we can say it is terminating decimal expansion. Let us do the division. 23 divided by 200. Okay. Into how many times? 0 times. 0 times 200 is 0. On subtracting, we'll get 2. Bring this 3 down. 23 how many times? 0. 0 times 200 is 0. On subtracting, we will get 23. Nothing to bring down, so we are putting decimal, and adding zeros. So this 0 now we can bring down. So we got 230. How many times? One time. One time 200 is 200. On subtraction, we will get 30. Then we can bring next 0 down. 300. How many times? One time. One time 200 is 200. 300 minus 200 is 100. We can bring next 0 down. So we'll get 1000. How many times? 5 times exactly. 5 times 200 is 1000. 1000 minus 1000, we got 0 as a reminder, right? It is finished. So it is a terminating decimal expansion. Terminating decimal expansion, right? 0.115. I am using a traditional method of division actually. See, if you are experienced, no problem. You can just skip all these steps. You can go straight away. Okay. But focusing on all the students, I am doing that step by step. Okay, without making the shortcuts. Now let us go for the next one. 129 divided by 2 raised to 2 into 5 raised to 7 into 7 raised to 7. Here, other than 2 and 5, we have 7 also. So what is the decimal expansion? Non-terminating, non-terminating, repeating, non-terminating, recurring. Okay, so here 2 raised to 2 into 5 raised to 7 into 7 raised to 5, we are getting a big number. Okay, a number we are getting 52752187500. Okay, so we have 129 on division. On division, see, even after trying this method, this much digit, I didn't get the repeating block. Okay, so you need further calculation. So I have limitation on the screen. So fine. So this is a challenging question for you. You can try yourself and find the repeating block. Maybe 10 digit I have tried. Maybe after 10 or 15 in that range, you will get the repeating block. Okay, fine. Okay, that try yourself. And those who get the answer, they can put in the comment box. Fine. Okay, let us go for the next one. 8th one. 6 by 15. Prime factorization of 15 is 3 into 5. Numerator we have 2 into 3. So on cutting, we will get 2 by 5. So reminder, denominator contain only 5. Right, so it is in the form of 2 raised to m into 5 raised to n. So it is terminating decimal expansion. Let us see. 2 divided by 5. How many times? 0 times. 0 times 5 is 0. 2 minus 2 is 2. Nothing. So put a decimal, and we can add zeros. Bring this 0 down. So we got 20. In 20, how many times? 4 times. 4 times 5 is 20. 20 minus 20 is 0. Finished. Terminating. Terminating decimal expansion. Okay, ninth question. 35 by 50. What is the prime factorization of 50? That is 10 times 5, right? 10 times 5. Okay, in numerator we can simplify. So we end up with 7 by 10. 10 when we are doing prime factorization, we are getting 2 times 5. It is in the form of 2 raised to m into 5 raised to n. So it is terminating decimal expansion. Let us do the normal division. We have 35. 35 divided by 50. Okay, digit by digit. Directly we can see 35 how many times also we can do. But as a procedure, we are taking first digit, how many times? 0 times. 0 into 50 is 0. 33 minus 0 is 3. Bringing next digit down. 35 how many times? 0 times. 0 times 50 is 0. Subtract, we will get 35. Nothing to bring down, so put decimal. In the quotient also decimal. Add zeros. Okay, that 0 you can bring down. So you got 350. In 350, how many times 50 goes? 7 times. 7 times 50 is 350. 350 minus 350, you got 0 at the remainder. So finished. We got a terminating decimal expansion. Terminating decimal expansion. That is 0.7. Now, 10th one in this section, last one. 77 by 210. Prime factorization of 210 is 2 into 3 into 5. Okay. On simplification, actually, we have some common factors are there 7 and 7 that can be cut, and we can make the top prime in the simplest form. So we are prime factorizing 30. So on prime factorizing 30, we got 2, 3, and 5. So other than 2 and 5, we have 3 also. 3 also. So we can say it is non-terminating but repeating, recurring. Let us do the division. 77 divided by 210. You are taking 7. How many times? 0 times. 0 times 210 is 0. On subtraction, you'll get 7. Bring this 7 down. In 77, how many times? 0 times. 0 into 210 is 0. Subtract, we'll get 77. Nothing to bring down, so we are giving a decimal in the dividend and also in the quotient. Okay, we can add zeros, as many zeros. Bring this 0 down. 770, how many times? 3 times. 3 times 210 is 140. Bring next 0 down. So 1400. How many times? 6 times. 6 times 210 is 1260. On subtraction, we will get 140. Bring next 0 down. So 1400. How many times? 6 times. 6 times we will get 1260. Subtraction, we'll get 140. Bring next 0 down. Next 0 down. So we get 1400. How many times? 6 times. 6 times 210 is 1200. Goes on. See, we get all 666. So repeating block is 6. After 3, we are getting 6 is repeating continuously. 6 is repeating continuously, right? So 77 by 210 is 0.3666 repeating. So this also can be written as 0.36 bar only on 6. Some syllabus will say 36, and we will put a IGCSE at Excel all there. They are doing like this. Indian syllabus, we are doing a bar. Clear? Fine. Now, let us go for the next session. It is third question. 1.4, third question. What is the question? The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form P in the P by Q form, right? P comma Q. What can you say about the prime factors of Q? I mean the denominator. So we have a number 43.1, 2, 3, 4, 5, 6, 7, 8, 9. So it's terminating, right? Terminating decimal expansion. So it's a rational number if it is in the form of P by Q. Q, what will be the specialty of Q? Q, the prime factorization of Q will be in the form of 2 raised to m into 5 raised to m. Okay, fine. So this number has a terminating decimal expansion. It is a rational number of the form P by Q, and Q is of the form 2 raised to m into 5 raised to n. The prime factors of Q will be either 2 or 5 or both. That is the conclusion. Next question. Sub question 2. Here our decimal expansion is 120, 1200, 12000, 12000. Non-terminating, non-recurring, non-ending, non-repeating. So it is irrational number. Non-terminating, non-recurring, non-ending, non-repeating is irrational. So we can say that the decimal expansion is neither terminating nor recurring. Therefore, the given number is an irrational number. Irrational number. Okay, last question in this session. Okay, they have given Decimal expansion is 43.123456789. All these numbers are repeating again and again. Again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it is keep repeating, goes on. So it is non-terminating but repeating. So it will be a rational number. It will be a rational number, right? Rational number, which form? It is in the form of P by Q, right? But since the decimal expansion is non-terminating, recurring, Q will be not in the form of 2 raised to m times 5 raised to n. Clear? So let us conclude. Since the decimal expansion is non-terminating recurring, the given number is a rational number of the form P by Q, and Q is not of the form 2 raised to m into 5 raised to n. That is, the prime factors of Q will also have a factor other than 2 or 5. Clear? Okay, fine. So that is the end of this session. We can see with new portions. Okay, fine. Any doubts you can ask me as usual by email or WhatsApp. My online students can ask me in the class also. Even in the comment section, you can comment your doubts or opinion. I will see it and I will reply. Okay, see you in the next class. Goodbye.